in this review, we're going to study one of the very important tests for convergence called the limit comparison test. So it's called the limit comparison test. So one of the benefit of this is, so what we normally call LCT. One of the benefit of this test is any problem that you can do under direct comparison, you can do using this test. So that's we need to remember. So any problem that can be done using the direct comparison test can be done using the limit comparison test, probably much easier, okay, in a easier way. Most of the time, not always, most of the time. So so that's something you remember. So if you have a problem that you can do using direct comparison test, you can definitely do that using the limit comparison test. Okay, so again we also need the P series. So P series. So what's the P series test is, so we have sigma n going from 1 to infinity, 1 over n to the P, which gonna converge if P greater than 1, which gonna diverge if P less than or equal to 1. So that means if you have 1 here, so on this side open at 1, on this side it's gonna converge, on the other side it's gonna diverge. Okay. So so this interval is 1 to infinity, it's gonna converge, negative infinity close at 1, negative infinity close at 1 is gonna diverge. Those are two intervals. Okay, so let's try the theorem. So what the theorem is about, so the theorem it is the limit comparison test. So suppose that sigma an and sigma bn are two series with positive terms. If now what we're gonna do, we can take the limit. If the limit n goes to infinity, we can take the ratio an over bn. Let's say you get a number L which is not equal to 0. So you get a number. So then what happened then? Either both converge or both diverge. So it says that they behave the same way, either both converge or both diverge. It's kind of interesting. Okay, so one of the very important note here, so what you need to do when you do problems, you only need to look at the dominating term. Okay, only look at the dominating terms of the numerator and the denominator, So you don't worry about the other terms. So that's one of the very benefit of this technique. That's why the problems can be done very easily, because you don't want to look at the other terms. You only need to look at the dominant terms. So let's try to look at some examples just to see how this is gonna work. So so as a first example, we can do this one. So remember this problem. So the question is test for convergence. for convergence. So you can see that this problem that you cannot do using the direct comparison test. So 1 over n squared minus 1, because the limit is in backward, the wrong direction. So what you do, look at the dominating terms. So if you look at the problem, so we're going to versus. So what you do, you're going to compare this with, look at only the dominating term. Dominating term of the numerator is 1. Dominating term of the denominator is n squared. That's it. So now what we can do, so in this case, so you can see that a n equal 1 over n squared minus 1 and b n equal 1 over n squared. So what you do, take the limit, n goes to infinity, a n over b n, so it's a limit, n goes to infinity. We write this one like that, and then we may make it upside down and write, because it's a division, so that means make it upside down. Now you can see that when n goes to infinity, you can ignore those 1 here. So that means, so these two are the terms, but they are equal. So that means your limit going to be 1, which is not equal to 0. So if you do it like that, it's always 1. If you just pick the dominating term from the numerator and denominator, it's always going to be 1. That's one of the shortcut. So you can see that it's not equal to 1. But we know that the sigma 1n is a convergent series. So you can see thus by the limit comparison test, the series sigma n going from 2 to infinity, it can be 1 because at 1 it does not exist. 2 to infinity, 1 over n squared minus 1 converges since sigma 1 over n squared is a converging P series, with P equal 2, which is greater than 1. So that's the complete argument. So let's try to look at another one. So this is the next example. So so how about this one, sigma n going from let's say 1 to infinity, 1 over 3n minus 1, something like that. So again, we're going to look at the dominating terms. So the dominating term is 1 over 3n. So that means you're going to compare this with n going from 1 to infinity, 1 over 3n. You can see that you can write this one as 1/3 to n. So that means this is a geometric series. So this is a geometric series with r equal 1/3, which is less than 1. It's positive, we don't have absolute sign, less than 1. So that means this will convert. So, and then also we know that in this case, if you take the limit, so let's look at those two terms. So this is we're going to consider as an, this one we're going to consider as bn. So if you do a and bn, then we can see limit n goes to infinity, an over bn, which is limit n goes to infinity. You're going to get 1 over 3n minus 1 times, again as before, it is 3n over 1. You can see that if you look at the domain terms, they are equal. So that means the limit is 1, which is not equal to 0. So you can say, so by the limit comparison test, the limit comparison test, the series n going from 1 to infinity, 1 over 3n minus 1 converges, because the other one converges. Okay, so let's look at one more example. So the next one is this one, sigma n going from 1 to infinity into the 5th minus n cube sine n squared plus 7 over 5 n to the, let's say, 14 plus square root n, maybe minus 3. So it doesn't really matter whether plus or minus here, because we only look at the dominating terms. So minus 3. Let's take the square root of this. So you can see that if you get like algebraic expressions like that, so the best thing would be to use the limit comparison test. So what are you going to do? You're going to compare this with, so this is the dominant term of the numerator, this is the dominant term of the denominator. But we're going to notice something first. So you can see, note that the sign is in between, sine n squared is in between 1 and negative 1. So that means n cube is not a dominating term here. N fifth is dominating term because it's just between 1 and negative 1. So so because of that, we can just consider the dominating term here. So that means we're going to consider this one with, so versus, let's pick the dominating term and go from 1 to infinity. So here n fifth is the dominating term. Here you're going to be 5 n to the 14 square root, that is the term. So let's simplify this a little bit. So you can see, if you simplify this, you're going to get n fifth over square root 5 n to the 7th. So if you simplify this a little bit more, you're going to be 1 over 5 n to the squared. So that's what you get. Okay. So so you can see that in this case we know an, but this is the bn, so we can take the limit. So I'm going to call this is an, this whole term is an, and we're going to call this is bn, so we can take the limit as before. So the limit n goes to infinity, an over bn, limit n goes to infinity. I'm not going to write an this time because it's too much. That's, yeah, but yeah, that's okay. So in fifth, minus n 3 sine n squared plus 7 divided by 5 n to the 14 plus square root n minus 3 square root times upside down, so it's a square root 5 n to the squared over 1. But you can see that as before, we only need to worry about the dominating term. When n goes to infinity, this does not work for other case, n goes to infinity. So that's one term, that's one term, and you can see that this kind of simplifies to 1 over square root 5 n squared, but that's exactly cancels with that. So that means your limit can be 1, which is not equal. Yeah, so that's one of the thing that if you do it like that, it's always 1, always 1. Okay, so it's 1. So therefore you can say therefore by the limit comparison test, the series an converges since sigma bn is a converging p series with p equal to, which is greater than, not equal, that's not equal sign, which is greater than 1. Okay, so you can see that the amazing power of the limit comparison test is very powerful, very powerful. Okay, so you can try these questions. So I'm going to give you a few questions for you to try. So you can try this sigma, let's say 1 over n to the pi over e. Think about that. Sigma n going from 1 to infinity. Actually, you can do this problem for direct comparison. It's not limit comparison. It's just a basic direct comparison or p series. So think about that. Okay, how about this one? 3 over n 1 plus 1 over n. And also, how about this one? N going from 1 to infinity. This one is tricky. 3 over n to the 1 plus 1 over n to the n. So I'm going to recall a result from calculus. We know that the limit n goes to infinity, 1 plus x to the n is e to the x. So this is one of the result that might helpful in the last one. Okay, so this is the end of a limit comparison test.